Well, it may come as no surprise to you that inverse transforms work the same way. Well, maybe it will be a surprise. So anyway, let's find the inverse transform of 2s plus 4 over s minus 3 quantity squared. And of course, we'd start off by using partial fractions. 2s plus 4 over s minus 3 squared is a over s minus 3 plus b over s minus 3 squared. And so if you multiply both sides by s minus 3 squared, you got 2s minus 4 equals a times s minus 3 plus b. So therefore a has to be 2, and negative 3a plus b has to be 4, so b minus 3a is 4. That's another way of saying it, so b has to be 10. So what we want now is a transform, the inverse transform of 2 over s minus 3 plus 10 over s minus 3 squared. So for this, it's 2 times e to the 3t. For this, it's 10 times the inverse transform of 1 over s minus 3 squared. Well, stop and think. Transform of 1 over s squared would just be t. But the fact that it's displaced by 3 units means it'll be e to the 3t times our t, times the 10 constant multiplier we had in the front of the thing. Okay? And looking at another one, find the inverse transform of s over 2 plus 5 over 3 divided by s squared plus 2s minus 6. And of course the first thing you would try to do is factor that, and it doesn't. But we can rewrite the denominator in a useful way by completing the square. Make that, add the 4 to this to make it a perfect square, but then we'd have 2 units left over, and so it's s plus 2 squared plus 2. And now we actually have sort of a separate problem, and this might be a little tricky, so think about what you have to do here. We have to make this be such a way that the s plus 2 is here and here for the cosine function. And so we can factor out the half, divide this into 2 separate fractions. There's the factoring out the half, that's this 2 that's in the basement. S plus 2 over s plus 2 squared plus 2. And then for this one, well, we want this to be s plus 2 squared plus 2, so the square root of 2 is going to have to be in the numerator. We already have a 2/3, so if we factored out the square root of 2 over 3, we would have the same expression. And now it's starting to get like something we can use for the inverse transform. And so the inverse transform of this, use the linearity, factor out to a half. And so it's a half times the inverse transform of this, and then square root of 2 over 3 times the inverse transform of this. That's what I'm trying to say with this step, although I can see that I got out of my comfort zone here a little bit. So anyway, then we'd say, well, okay, what we need to do is look at this part, and of course you can recognize this would be the same as the cosine but displaced 2 units, or translated 2 units if you want. So it would be cosine displaced 2 units, so e to the negative 2t times cosine of square root of 2t. And the half is a multiplier in front of the whole thing. Now this one, square root of 2 over 3 times, okay, we're going to displace sine of square root of 2t by that same factor, e to the negative 2t.